Hi everyone. Again, thank you for joining. My name is Noah Zeef, and I'm an applications engineer here at RIZE 3D. And today we'll be talking about our flagship machine, the full-color 3D printer, which we call the xRIZE. We'll be talking about its patented technology in depth, as well as how we stack up to other full-color additive technologies. And we'll also have some time for questions at the end. There will be a chat box that you can type your questions into. To answer those questions, we'll also have Anthony Francis, our Director of Customer Success, as well as David Silverman, our Lead Process Engineer. So beginning with some company background, we were founded in 2014 in Boston. We shipped our first machine in 2018, so we're around 4 years in development. Our founder is a material scientist who's been heavily involved in developing full-color technologies and materials for over a decade. And our technical leadership also comes from distinguished 3D companies and backgrounds as well, primarily from Z Corp. And together we've developed a unique patented technology which we call augmented polymer deposition, or APD. We'll go over in a minute. And our partners include Dassault Systems and Synopsys, both billion-dollar software companies, with Dassault Systems particularly focused on 3D software. We're especially proud of that partnership because we're actually the first 3D hardware company to land an investment from Dassault. And this has allowed us to gain some very distinguished customers ranging from NASA to the US Army to some well-known universities. Some are listed here. And we've also gained some industry recognition, especially for the safety of our materials. In particular, we are the first 3D manufacturer in the world to obtain the UL Green Guard certification for our printers, inks, and materials, which basically just makes the machine safe to operate in any home or office setting. So the basics of our augmented polymer deposition, or APD technology, consists of two printing technologies, which is why we refer to it as additive 2.0. The first is a standard additive technology, which we call material extrusion, and the second is an inkjetting technology common on office and home paper printers. And so beginning with material extrusion, you may know by a different name, FDM for fused deposition modeling, or FFF for fused filament fabrication. They all essentially refer to the same technology. It's the most basic type of 3D printing technology. And to cover the basics, it all starts with the spool of filament. We specifically use a composite filament called RIZE GF, which is a durable plastic filled with glass fibers. And the beautiful thing about material extrusion is that the exact amount of material you need is unspooled for each print. So it's a very efficient process. There's no need for fully filled baths or build volumes like in SLA or SLS or binder jetting. And once you're done with the spool, you could simply unload it, and RIZE spools specifically can be stored pretty much anywhere. And so as the spool is unwound, the filament is melted and extruded through a nozzle, layer by layer, until your part is built up, often with support. Here the support is designated by the light blue structures, and the model is designated by the dark blue. And the last part is just to peel away those support structures so you're just left with your desired part. And on to the second half of our APD technology, we incorporated a very well-known printing process, which everyone on this webinar has probably used at one point or another in an office or a home. It's inkjet printing. And the basics of this technology are pretty straightforward. The substrate is a thin piece of paper, which flows through the machine according to the green arrows. And standard ink colors, which include cyan, magenta, yellow, and black, are inserted into the machine in cartridge form. And it's through a printhead that moves back and forth along the x-axis that these inks are expelled. But more specifically, it's tiny ink droplets that are expelled through hundreds of microscopic nozzles that print your text or image as precisely as possible. And so what we did to combine these technologies was focus specifically on the expulsion mechanisms. So we concentrated on the extruder from standard material extrusion and the inkjet channels from standard inkjet printing. And the result is the RIZE solution. So it's a compact carriage which consists of mechanisms from both technologies. Here you can see a carriage specifically from our xRIZE machine, which has one extruder and 3 inkjet heads. Each inkjet head has 2 inkjet channels, so we have a total of 6 channels. 2 channels are used for a special release ink that we've developed, which we'll talk about in a moment, and the remaining 4 channels are used for typical CMYK colors, so that cyan, magenta, yellow, and black inks. But diving deeper in why exactly we incorporated these technologies together, the initial process starts off the same as regular material extrusion with a layer of support material. This is meant to be broken off after your part is finished printing. But before we start printing the model material, we begin to leverage the inkjet technology by expelling a layer of release ink. And then on top of that, we extrude the model layer. And basically this release ink in between the support layer and model layer will help the support break away much easier and allow for a clean bottom surface finish on your part. And then we use the remaining 4 inkjet channels to dispense the standard CMYK colors. And just like inkjet printing, we can mix and match these inks to print in over 800,000 different pigments. And the result is strong composite full color parts that are easy to post-process and serve many unique industries with many unique purposes. So to really drill it home, here's a quick animation of the process in action. You can see the composite plastic is extruded first, and the inks are deposited on top. And the result is vibrant and durable parts like you see here. So now to the comparison portion of the webinar, we'll be using simplified graphics like the one you see here, which shows our extrusion technology and a simplified version of the inkjet technology combined onto our printing carriage. And we'll be using these simplified graphics to briefly break down the technology behind the other commercialized full-color 3D printing methods out there. Specifically, we'll be focusing on binder jetting, multi-jet fusion, and material jetting. I should note there are other full-color 3D printing methods out there. However, we found these to be the most prominent, so we'll be taking a look at why these add as much value as they do and what specific categories RIZE can stand to offer a bit more. So beginning with binder jetting, this process has been commercialized by the ProJet lines of 3D systems machines. You may also know it as color jetting or CJP for color jet printing. This process also includes CMYK inks that are jetted through microscopic nozzles, the main difference here being the substrate. So instead of expelling the droplets onto melted plastic filament, you're dispensing them onto loose powder. So here the inks are actually serving two purposes. They're not only providing color, but they also have a binding agent that holds the particles of loose powder together so you could build up your part. And here you could also see there's a spreader that acts like a plow, which disperses a new layer of powder as the build plate is lowered and your part is built up. And it's also important to know with this process that it will not often give you a final part. The part is quite fragile because the only thing holding it together are those binding agents. So what you're actually left with is what we call a quote-unquote green part. And it's only after using separate post-processing equipment like an air blaster can you get rid of the extra powder, and then dipping the part in a glue are you able to bring out the colors and strengthen the part. So a brief comparison here between RIZE and full color binding jetting machines. RIZE is a solid base system with its input being that composite glass filled filament, our Rizium GF. And binder jetting, as we mentioned, uses a powder material input. Specifically, it uses a plaster-like compound, so we call it a powder-based system. And in terms of layer heights, material extrusion by nature creates layers thicker than most other additive processes. So you will see thinner layer heights in binder jetting. However, I should note we are releasing a 0.125 millimeter layer height profile later this year. In terms of post-processing, RIZE is definitely a more economical option, especially when comparing it to a process like binder jetting, where not only will you have to purchase a separate air blaster to remove loose powder, but you will also have to purchase additional glues and epoxies, which bring me to my next point, safety. RIZE will, when you're working with a RIZE machine, you won't encounter any toxic skin irritants like glues or epoxies. You won't have to wear gloves or masks or respirators to keep from inhaling loose powder. You can easily peel away the support with your hands, and the material is 100% safe and recyclable. And I can also tell you from experience that not only is binder jetting glue super toxic, but it also only strengthens the part so much. So if you want to ship your part anywhere, you will still have to have some very good packaging skills. And RIZE is a great alternative here because the Rizium GF composite material we use is very durable. In terms of strength, it's comparable to a polycarbonate plastic. And of course, the most important category, and one where we're really unrivaled in when it comes to full color additive, is price. Binder jetting and color jetting printers specifically will be at least 2 times the price of our xRIZE machine, and that's before the need for more post-processing equipment. And this also translates into consumables and part costs as well. With our Rizium filament being less expensive than color jet powder, and our ink cartridges having to be replaced less than half the time as in color jetting systems. So moving on to multi-jet fusion, also known as MJF, which is actually another full color additive technology our founder helped develop. Today it is highly commercialized by HP. And unlike APD and binder jetting here, multi-jet fusion uses special liquid agents that are reactive to selective heating, similar to SLS. And to be specific, the first nozzle picture here, which dispenses the dark gray agent, makes up the infill, and the light gray agent is dispersed on top of that to act as a primer for the CMYK colors that are dispensed on the part last. And you can also see here, this process is similar to binder jetting in that it is a powder-based system. So it utilizes a spreader to evenly lay out each layer of powder as the build plate is lowered and the part is built up. So onto the quick comparison, as we mentioned, RIZE is a solid-based system using our composite filament. Multi-jet fusion is a powder-based system. Specifically, it uses PA12 powder. And again, since the powder particles are smaller than typical beads of filament extruded during FDM, multi-jet fusion will have thinner layer heights. However, since multi-jet fusion is a powder-based system, you will need to purchase that separate air blaster or a bead blaster for post-processing. Unlike binder jetting, however, you won't need a glue or epoxy post-processing dip here to harden a quote-unquote green part, since the powder particles in multi-jet fusion are fused together with that heat source. And I should also mention that multi-jet fusion is a humidity-sensitive process, so you will also need to invest in humidifying equipment for optimal results. The solid versus powder system also reinforces the safety of our process. In multi-jet fusion, you're still dealing with those very small powder particles that can be inhaled, so masks and respirators are highly recommended. And finally, cost, especially for machine cost. Multi-jet fusion machines typically run 3 times as much as our xRIZE. And again, that is before the need for any post-processing equipment. And the same idea goes for part cost. It's also worth noting that both binder jetting and multi-jet fusion powder systems can only print solid infill. So if you want a hollow part with these systems, you will have to incorporate and then often fill a drainage hole for the powder to drain out. So with RIZE, not only can you save on material by printing a variation of infills, but you will save on time without the need to empty or cap any drainage designs. And finally, onto material jetting, which you also may know as polyjet. It is currently commercialized by Stratasys and Mamaki. And this system is a unique full-color 3D system in that it is the only one on our list that is a liquid-based technology that uses CMYK colored resins to build up its part. So there's no powders or filaments or anything like that. Specifically, it's UV cured resins, so they go from a liquid to a solid, and the UV source here is incorporated on the printed carriage. And as you can see here, the build plate is lowered, and each layer of solidified resin is built up on top of one another until your part is complete. It's also important to note that these parts are often printed in a coat of support material, and the support coat then has to be post-processed away with an additional water jet machine or a chemical bath. And onto the quick comparison. We know that RIZE is a solid-based machine or solid-based system that uses that composite filament. Polyjet and material jetting are unique, and that is a liquid-based system using those UV cured resins. The liquid-based system does give Polyjet the ability to print with extremely fine droplets, so there is a substantial difference in layer height here. However, just as with the powder-based systems, the liquid-based systems do require additional post-processing equipment. It's most often that you require a water pick instead of an air blaster or a bead blaster to wash away the support. However, you can use chemical baths to remove the support with this technology as well. So safety is definitely a difference here. Handling our filament is straightforward and safe, whereas the liquid resins with Polyjet are toxic. They are skin irritants, so PPE is definitely recommended. This is also especially true if you incorporate a chemical bath for post-processing. The UV source for these systems does solidify Polyjet parts, so they aren't dubbed quote-unquote a green part that needs further strengthening. However, without the melting fusion that's present in our APD process and in multi-jet fusion, these parts can be quite fragile. And it's also important to note that Polyjet parts become especially brittle, and the color will fade with overexposure to UV. They will warp in heat as well, so compared with RIZE parts, they are more UV resistant. They won't warp in heat, so you won't have to worry about leaving them by a window or leaving them outside for too long. And finally, when it comes to cost, there is a significant difference in machine and part cost between these technologies, which makes sense because of the trade-off that typically exists between layer height and price. With the layer heights being as thin as they are in material jetting, the cost for their material and machine is often at least 3 times more than our xRIZE. And with that, we'll move on to some additional info that we think is important to note for xRIZE users and about the APD process in general, beginning with software, which is not just important for 3D file prep in general, but it's especially important when you're dealing with files that contain texture maps, shading, and colors. Our free slicer is called OneTouch, and it does offer some of these capabilities. So you are able to color models or color certain faces of models a single color. However, for more complex texturing and shading like the turtle you see here that we printed, you'll want to use a dedicated design software, which could be Blender, ZBrush, Maya, or anything similar to that. The main purpose of our OneTouch software is the slicing component. So it generates a G-code for the material extrusion head, and it generates bitmaps for the ink jetting nozzles. Another thing to note about our process is that the color exists on the outer perimeters of the parts. So if you were to cut up a part like we did here, you'll find there is no pigment on the inside. We do this to save on inks so the user can get the most out of our material. And another very important note here is that most typical FDM rules do still apply. So even though we're adding the full color capabilities from ink jetting, many of the design capabilities and limitations of standard material extrusion machines exist on our machine as well, such as minimum wall thickness and fine detail tolerance. We typically recommend 2 to 3 millimeters if possible, so a detail can be sliced and printed properly. The main exception to this rule, however, is our unique support removal. So since we can leverage our ink jetting capabilities, to inkjet that layer of release ink in between support and model layers, our support breaks away much easier than standard extrusion machines, and we tend to have better bottom surface finishes as a result as well. So here we also wanted to include a brief FAQ section to hit on some common questions we get. A popular one we get is how the multicolored filament is extruded, or how do you extrude the many different colored filaments? But as you know from this webinar, for our full color models, we only extrude one color filament. It's our white composite filament, the RIZE GF. It's only after the filament is extruded that it is colored using those CMYK inks. Another metric we are inquired for a lot is the cost per cubic inch, and it often surprises people just how little additional cost the colors actually add to the overall cost. So this 1-inch cube, for example, costs $2.68 in consumables. However, the far majority of that price is our filament composite. Only 44 cents of the cost for this cube accounts for ink usage. And finally, an important topic we work with our customers on is routine maintenance. We do have procedures like printing a test page and printing calibration blocks that we recommend to be done weekly. However, they're all pre-programmed into the machine, so it's as simple as pressing a button and letting it run for a bit. These procedures can take anywhere from a few minutes to an hour, so machine downtime is minimal. And we also provide all our users with a 3-month maintenance kit included with the machine purchase. So finally, to review some key takeaways from the APD process and the RIZE solution in general, first and foremost, if we haven't drilled it home already, we are very proud to be the most affordable and accessible full-color additive technology on the market. And that's not only regarding our machine, but our consumables and parts as well. But at the same time, you're not, and just as important, you're not sacrificing strength or full-color capability. So our composite materials have proven strong enough to last as end-use parts, and the UV and chemical resistance of our materials keeps color during those end uses, much better than a lot of our competition. And this is all while keeping users safe. So our Green Guard certification ensures users won't have to worry about any harmful emissions from melting the plastic, and that's no matter where the printer is located. It could be in a small office or even a living room like mine is. And finally, they're easy to maintain and operate. The xRIZE was designed and is continuing to be perfected as a plug-and-play solution by our engineers. And should you ever encounter any issues, we have a great and knowledgeable team willing to help with any questions. Which brings me to the final part of our webinar. We thank you if you made it this far. At this point, we'll open up the floor to any questions from myself, Anthony, and David, our expert engineer. If you write in the chat, check the chat quick, we will be happy to answer any questions. I'm not seeing any questions in the chat at the moment, but I did have a couple prepared, one of them being build volume. A lot of people inquire about that. Our build volume is 12 by 8 by 8 inches, which is 300 by 200 by 200 millimeters. So it is pretty generous for full color options. And another point I would like to make on that is you can print on them wirelessly. So we do offer a RIZE Connect solution as well. So you won't have to be walking back and forth between your printer. You can do it wirelessly. I do see a question here. All right, just having some technical difficulties. So if I'm sorry, if Dorian, if you're on the chat, are you able to read any of the questions in the chat? I can only see a portion of them here.
Yes. Let me read them out for you. There's a couple already. Let's see 5 different ones. The first one is from Franek Hasyuk. The question is, how does your method compare to what a DaVinci full color FDM machine uses?
So I could speak on that, David, if there's anything you want to speak on that one first.
Sure. Yeah, it's a good question. So their technology, I believe, utilizes PLA and water-based inks. I don't think, you know, I think the fundamentals are pretty similar, but I believe what they are able to do doesn't get the same, you know, resolution of color and the same depth of color. We just have a larger gamut of color than they do, and that's just because of the way we've engineered our inks to work with our composite material. That, and we also have the release ink, which is going to give better overall surface finish, like on supported surfaces. Those are probably the biggest differences.
Right.
Next question from Thomas Taubert. Sorry if I mispronounce your names, guys. Great webinar. Nothing serves 3D printing / additive manufacturing OEMs more than educating customers. A side question, can you explain a bit on the MJF process sensitivity to humidity, ambient, and powder material?
Sure. So I guess initially I would say that if you look at the Multi-Jet Fusion handbook, they recommend a humidity level maybe like 20 to 30% higher than typical room temperatures. Whereas, you know, the RIZE is made to, you know, perform well in standard humidity. That's kind of all I could say for the specifics of that. I don't know, David, if you could say a bit more on the humidity levels.
Yeah, I don't remember what they recommend for powder. It is quite low. Typically, you also want to be like in a controlled environment for that. But you know, for our plastics, they absorb almost no moisture. I mean, I run my at home. I have my xRIZE and RIZE 1 in my basement, which, you know, is pretty high humidity and no issues. So you don't need any special storage. You don't need to dry them out before use. They'll continue to work. You can come back a year later, and it still won't have any moisture absorbed, even in a, you know, 50+% humidity environment. It'll still be fine. Which is very different from if you've used other desktop printing materials like, you know, PLA, ABS, or nylon. Certainly not the case for us.
That's a great point.
Great. Next question from Deepak. Is printed color Pantone validated?
No, right now we, I mean, you can get into that, Noah, but right now we do not have any Pantone certifications or validations.
Yeah, I would just build on that. It is interesting if you you know, look into Pantone matching for 3D printing. The Pantone spectrum is actually different from the typical Pantone spectrum that has been validated by, you know, paints. So when someone says like even their 3D printed part is Pantone, you know, matching, it's actually not the same Pantone spectrum as paints or something like that. It's actually a separate spectrum that was developed just specifically for 3D printers.
Great. And Deepak has a follow-up question. Are there flexible materials also available, such as TPU?
Yeah, I can talk to that. We are developing TPU right now that will accept color. We don't have a release date for it, but if you've got an xRIZE, it'll be compatible with it as long as you have our new extruder. But that is currently in development. And if you have any specific any questions or any potential applications for that, you know, feel free to reach out to our you know, sales or customer service team. We'd be happy to talk to you about that.
I am able to see the questions here now, Dorian. Thank you. One I see here is, are any of your customers using the parts for final production parts, or is it just for prototyping? So these parts can definitely be used as end-use parts. Just this week, Anthony and I were on a call with one of our clients who uses the printer to print parts that help fit in glass windows, actually here in NYC where I'm located. So they were able to print these, durable composite parts on their printer, able to add any markings using our inks, and they are, installed in a lot of these windows to help them, fit flush with walls. So they can be used as in-use parts. That's just one of many examples. Let me see here. I see one question here. Is there a failed print recognition? So I don't think there's a failed print recognition for in-situ monitoring. But of course, if you run out of any materials during a print, the print will stop, so you can reload any filaments or inks and you can resume. So you won't lose your prints if you're several hours in or 90% done or something like that. I don't know if there's anything else you want to add to that, David.
No, there's no camera in the machine either, so that's typically how some of that detection software works. But no, you covered it.
Right.
I see a few more questions if you want me to read them.
Yeah, please.
Out to you. So first question from Gideon, just the price of the machine.
Yeah, the price of the machine. Actually, I don't know if Anthony's on the call. If maybe he can speak to that a bit.
Yeah, hi, I'm here. So the machine is actually priced competitively against the competition, and you can certainly reach out to our sales team and we'd be more than happy to provide a quote.
Okay. Anita Levine is asking, are you saying that RIZE uses only one type of filament and then it is dyed with ink as it processes? Is this material more expensive and different than regular filament?
Yeah, that's a great question. Yep.
Yeah, okay. So yeah, if you're using it to print color parts, it is only going to work with our filament. We have a couple different filaments, but only a few of them that actually work with the color. It's more expensive than average PLA material, but that material won't work with our colors. So it's kind of this is only really they're designed together, they're matched together, and they're optimized to work. So really, this is only for if you're interested in colored parts. If you're not interested in colored parts, but you are interested in our materials and also printing open source materials, we have two other platforms that will work for that. We have the 2XC and the 7XC, so you can go to our website and check those out. But for color parts, it only works with our materials in the xRIZE.
Thank you so much. I see that Mark is asking if there will be a recording of this webinar. Yes, there will be. We will send out an email in the next few days with the recording of this webinar. You should expect it probably tomorrow. And then Rick has a question. Are you able to shell colors for wear condition parts?
David, do you want to take this one?
Definitely. So that is an application we've seen some of our customers do. Right now, that's not like a setting that's enabled by default. So by default, I believe our color depth is 800 microns from the surface. But if you had a specific application where you needed a different depth in a certain location, we could certainly help facilitate that. That's just not a setting that's exposed to customers right now, just for user experience. But if it's the right application, we can certainly help you with it.
So I believe we covered every question currently. I don't see any other ones in here.
Awesome. Thank you, Dorian, for helping me out there. Thank you to everyone joining us for today's webinar. Again, this will be recorded, so you'll be able to get this this week. If you have any other questions, feel free to reach out to myself or David or Anthony. We will see you in a couple weeks at our next webinar. The title is to be determined, but thank you again for joining. And
No, sorry, no, to interrupt you. There's one more question.
oh yeah.
Anita is asking, I am in a school system, and to order supplies, we have to go with purchase orders. Will RIZE supplies be available by this means? Any education pricing?
I believe we do have an educational discount. Anthony, would you be able to shed some light on this one?
Provide a discount to educational use, and we can certainly work with the POs. That's not an issue. And just a last note, anyone who has questions, please reach out to us directly on our website. There's a contact us page right there, so you can just fill that out and shoot us an email. We'd be happy to help.
Wonderful. That's it for me.
Awesome. Thank you, everyone, again.